Okay, let's get started again. And so now I'm going to go over lecture number 1. If you came in late, see me at the break. I'll catch you up to see what's going on. If you did come in, or you have just come in, make sure you do sign the roster that's going around so you can get credit for showing up today, essentially. So this is going to be the boring lecture for those who have a Java background, and it's going to be interesting to those who don't have a Java background. So I want to talk about the concept of the object, and I want to orient you or give you a brief overview of Java as a programming language. This is not a substitute for a first course in Java, however, just so you know. It's not going to be how to program 101. It's going to be Java overview. Okay, so what is Java? It's developed by Sun, owned by Oracle. If you go through tutorial 1, you can see the download of the current website for the Java 2 download. If you do download it, well, you should download it, you're going to need to get two things. You're going to need to get what's called the JVM, and you're also going to need to get the JDK, which is the development kit for Java. It's a general purpose object-oriented language, very similar, and it's based on C and C++, actually more like C++, but C++ is based on C, so they always put them together when you say C, C++. Designed for easy web internet access, internet applications. I'll show you probably not until the next session, next in March, the applet kind of and the web kind of interface for it, but today we're just going to talk about the core Java. Widespread acceptance. There's a lot of third-party tools that work with it, a lot of different programs. And so in terms of what we're looking at for this particular course, any version of Java will work. You can do it on a Mac. You can do it on a Windows machine. It's cross-platform compatible, which is another selling point for Java in general. And if you have a background in C++, you're looking good. You actually have in fact, that's what most computer science software engineering students, that's the first language they normally learn is C or C++. And because there's so many different features, in fact, a lot of the programming syntax is the same. But I'm going to go through the syntax, I'm going to go through building a simple object and basic object-oriented terminology and concepts, which is the focus of this particular entry-level sort of lecture. And so you might have noticed I'm using a Mac. However, I'm going to do all my demonstrations on a Windows systems because I found that most students actually have Windows. So I have parallels on here with Windows, and I'll show you that as we go through the course. For downloading and installing, go to the bhacker.com website, look at tutorial number 1. It'll take you to the website. It'll download, show you what to download. If you're going to use an IDE for this course, Integrated Development Environment, Eclipse is the one I'm going to demonstrate with. Feel free to use anything you want. There's JGraphs, Eclipse, NetBeans. There's a ton of Java IDEs. And when I say IDEs, that's because Java actually doesn't come with an integrated development environment. It's basically a background compiler that runs on your computer that's probably on your computer already. If you have a MacBook, it's already installed, actually. You don't have to do anything. And you pick how you're going to write your program. So most people, like in the old days, used to use Notepad, or a text editor to write the text of the program. Very similar to C, actually, in the old days. But then nowadays, the more modern day programmers, they like the colors and the organization and the projects that you can create. So IDEs like Eclipse are very popular, and they're free. So you don't have to worry about buying software for this course. Everything is free. You can't use Microsoft Visual Studio. It doesn't support Java. It only supports Microsoft.NET. So Java, just another background thing if you're brand new to Java, is sort of like the .NET platform. In fact, Java programs run in what's called the JVM, or Java Virtual Machine. It's kind of like an operating system running on top of an operating system, sort of equivalent to what .NET has sort of accomplished. It's middleware. So .NET's the middleware platform for which the Microsoft products are running on. JVM, keep calling it JVM, or the runtime environment, is the middleware platform for which your Java programs are going to run on. When you compile a Java program, and I'll run through all that stuff today as well, You're not actually creating an executable file like you would in C or C++. You're creating a .class file, which is intermediate Java bytecode that runs in this interpreted environment, runs in JVM, which is why when you download and you install Java, you actually have to get two. You have to get the runtime environment and you have to get the development environment. So you can write programs, compile the programs, and also run the programs. And the best way to figure out how to do that, again, is to download or actually go to that YouTube video, tutorial number 1, and I'll show it to you. In fact, if anyone's having problems finding it at the lunch break today, I can run through it as well. And you can basically find out whatever version is the most current, download it, install it, and get your system up to speed. That's probably what you're going to want to do between now and the next session as well, because you want a development machine that you can actually work on. So, all right, so some features of Java. It's simple, it's easy, it fixes some of the clumsy parts of C or C++, no pointers. So the JVM actually works with the memory. In fact, I called it an operating system already. The JVM is an operating system you're installing on top of an operating system. It's giving you all of the memory management features, garbage collection, everything. Interface to the hardware, interface to other software, to drivers and stuff. It's setting the environment, so it's actually kind of easy to write programs that work with the JVM, essentially, without even thinking about it. And when you compile them into the intermediate code, the JVM processes everything. So in a lot of ways, it's easier. In fact, even working with threads is easier than the C++ environment. And it's rich with predefined class libraries, and we'll take a look at that as well. And it's purely object-oriented. You can program with C or C++ without actually programming in an object-oriented fashion. So this class is all about object-oriented design and focusing on the object concept. Well, the object is a class, and it's implemented by creating a class. So if you've never created a class before, you've never done object-oriented programming. And it's very easy to program in C or C++ without ever creating a class. Instead, you run everything by function. You have your main function, and that function calls another function, calls another function. But you're not making any instances of classes. You're not inheriting classes from other classes. You're not really, if you haven't done any of that, you can do that in C++. You can actually program without using object orientation. But you can't do that in Java, because Java is purely object-based. Even hello world is an object, as we'll see. So all of the functions are associated with objects, and we have what's called class files. Class files contain objects, object code that get instantiated. And I tried to call it I actually refer to it as a driver program, which is our main program, which is also a class that makes instances of the other classes. So it's just like, throughout today, just try to get familiar with the concept that everything is an object. Everything in the real world is an object, if you think about it. And all object orientation is one object talking to another object, or using the functionality of another object. So potentially you have the better code organization and reuse, if you think about it. And so object orientation is supposed to be able to create more efficient code, easier to use, easier to understand. It's actually supposed to be easier than traditional style programming. And it is an interpreted language, which means that .class file that gets created, and that's the compiled form of a .java file, is intermediate code. It's not executable code that contains runtime information. If you're not familiar with that concept, take an operating systems course. Operating systems have a feature called a runtime engine that takes executable code. It's usually in a binary, well, it is in binary format, and some sort of an intermediate or completely binary format that gets ran and interpreted by the operating system. The only thing different with Java is you take Java JVM, you load it on top of any operating system, and you can run any Java file. So you can probably imagine you can write the same program for Windows as you can for the Mac or for the Linux system, and it all runs the same because it's not relying upon the underlying operating system. Instead, it's relying upon the JVM. So as long as there's a JVM for the platform, the cell phone, the printer, anything that you're running it on, the program is going to run the same. it's just running in the JVM. So that gives you that cross-platform compatibility, which is the second point on the slide. And then we have this thing called Java bytecode that basically translated on the fly, meaning that we can load a file in, we can type the name of a file, run it, and it can actually go out and run other files. So not mentioned on the slide is this concept of distributed computing. So if you have these .class files and every object is in its own separate file, you can put them all over the network. And you can create a program that basically goes out and uses remote objects and things that are on different locations and bring it all together, which is how we get RMI and some of the other advanced enterprise computing Java concepts, which we're not really going to cover in this course. If you take my client server and the internet course, I talk about RMI, and I talk about JDBC, and I talk about some of the other Java connectivity components. This is a nice, actually, kind of prerequisite course to that course, actually, because we're basically just going to be covering the Java object-oriented features. So in terms of portability, the same application runs on all the different platforms. The size, the primitive, the data types, everything's always the same. So we don't have to worry about memory management or organization or anything. And the libraries are defined for portable interfaces, which kind of brings up the concept of, what features of object orientation, or what is object orientation in terms of its benefit or its use. And let me see if I can. Actually, we don't need that anymore, right? Let me write this on the board over here. I have an acronym I like to use called API, A-P-I-E. And, well, I don't have enough room on the board, but that's what I'm saying. I'm saying up high, a piece of pie, like you eat food. That's what object orientation is all about, and that's what I'm talking about in the class. And the A stands for abstraction. So the abstraction in our particular case, and we're going to talk about today, I'm going to cover abstraction, is the concept of the class, which is the object. And the class, by concept, is the template, or it's the blueprint that creates objects, and it's the object that is that level of abstraction that we're working with in terms of object orientation. The P stands for polymorphism. So that's an object being able to act like another object and be able to take input from the environment. I'll also talk about that today as well. And it's like, for example, a print object that's able to print text, that's able to print a picture, that's able to print numbers, all sorts of different things. So it morphs, it changes, so the object transforms into what it needs to be in order to accomplish the task that it's being asked to do, which is a core concept of polymorphism. And then the I stands for inheritance. And I'll actually talk a little bit about inheritance as well today. And the other focus is, being able to reuse. So a lot of people say, well, object orientation is about reuse, right? So it is. That's where inheritance comes into place. So if you have a class hierarchy where you've built classes upon other classes, you're not reinventing the wheel. Instead, you're taking from what you've already created, reusing it, and adding more functionality onto it. So you're extending the class, making it more useful. That's what the I is about. And then the E is encapsulation. Some people actually like to refer to it as information hiding. So once we create a class, we just use it. And we can use it and not have to worry about its implementation. And that actually brings up a couple of different, more complex concepts in terms of access methods, which some of you might be familiar with, but I'm going to go over that as well today. The public, the private, the protected interface. That kind of works with inheritance as well. But as long as we keep a consistent public interface to that particular class, we can encapsulate all of the interworkings. So it's kind of like using, if you're familiar with C or C++, like the printf or the cin, the cout object. As long as we know, say cin, we can take input in the form of anything, a text, a number, a string, and a system.out for the Java people System.en basically is an object that we're calling a method on the object, which I haven't talked about yet. It's going to say, take this in, output that. It's basic I/O kind of functionality. We don't have to worry about what that method is doing. We just call it run it because it's encapsulated as a concept. So from encapsulation comes that information hiding, they call it. From inheritance, we get reuse. From polymorphism, we get classes that are pretty functional, that are pretty good, that kind of adapt and change. And then abstraction is everything. Everything in this concept that I'm talking about is a level of abstraction from one point or another. So that's pretty much the core. If you were in an interview and someone said, well, describe object orientation, you can say, well, it's a pie. It's abstraction, polymorphism, inheritance. And that's just my way of remembering it. It's an acronym that a lot of students actually kind of like that because it's like easy to remember. It makes you hungry when you think about it, but at least you remember it. So. All right, so Java features. Continuing along, reliability is another feature. Extensive compile time, runtime, error checking. It's about on par with C or C++ and other languages. I don't know if I'd call it extensive. But it does actually come out and check a lot of different things in the environment. It does a lot of compile time, error checking. No pointers. That I would actually call more reliable. And if you're familiar with the old days of C or C++, when you started allocating your own memory, using dynamic memory allocation, using pointers and stuff, that's kind of hairy because if you make a mistake, you're going to end up with problems and it's going to make your program unreliable. But this is actually still in existence in Java, but it's built in. So the Java interpreter does all this stuff for you. You can't create a pointer on your own, but it's using pointers and it's using garbage collection and a lot of those concepts, which is going to be a later topic for this course later on. Automatic garbage collection, tracking, taking over, cleaning up. If you're not familiar with the concept of garbage collection, it's kind of like the garbage collectors, that come to your house, empty your can out when you leave them out the night before. They come in the morning at 6 o'clock or whatever, and they empty everything out. Well, so does the Java JVM. It goes around, every couple hours, whenever it needs to. Whenever it's running low on memory, the garbage can fills up, it kind of goes through and empties it out, gets rid of it, takes stuff out of memory, doesn't need to be in memory, essentially. Which is kind of the same concept, which is why they use the term garbage collection for it. Secure and security, that's actually, I would say, probably one of the best-selling features of Java as a language. You've got enhanced security features. And you think about the concept, you have a JVM that's running on top of an operating system. So the JVM has got its own security policy. It's kind of like an operating system security policy. In fact, there's policy files that end up becoming your worst nightmare when you start working with distributed objects. But they also become your best friend when you want to lock somebody out, lock another system out, make it so a file can't be downloaded or stored, prevent viruses or attacks and things of that nature. So security as a feature in the language helps out a lot. Memory allocation models, major defense, access restrictions, and I'll talk about the access restrictions today in terms of the private, public, protected, things of that nature. We're also going to look at multi-threaded applications later on. This is not going to be till the last part of the course. The last assignment deals with threads and stuff like that. And you'll see how you can actually create some really cool multi-threaded applications with built-in threaded libraries and capabilities where you just put the word synchronize next to something and all of a sudden you've written like 20 lines of C++ code because you don't have to actually worry about a lot of the different things you have to do manually. So if you're a C++ or C programmer and you've tried any of these features, you probably are familiar with some of the headaches that you may have gotten in the past with them. Java, you'll be amazed how easy it is, actually. So Java's not a bad language to learn as a first programming language because it automates a lot of stuff a lot of people had to do manually in the back, in the old days. But we have some sophisticated synchronization primitives and a bunch of built-in features in the language that can help us do a lot of thread programming really easily. We also have a dynamic environment. And I'll show you actually today how that could be your friend or it could be your enemy as well. Because Java class files are all stored separately, everything loads in kind of like an as-is needed, just-in-time kind of loading into memory. So you can actually change things in a program, change parts of a program, have it loaded in when you need it. Not load everything. In a C++ program, everything's all in one. It just loads all up. Java is different. It just dynamically loads things as it needs it. If one class isn't being used, it's not going to load it. So it's designed to adapt to an evolving environment. Libraries can be freely in instances without any effect on their clients. Interfaces can be changed. As long as we keep the public interface, we can actually do almost anything we want in terms of the class itself. So, and the class types themselves are, the class type is in runtime, so everything is dynamically allocated, dynamically run, so we don't actually have to worry about it. Java disadvantages. Are there any disadvantages? Slower than compiled languages such as C. Because we do have the JVM that needs to run, so we're loading an operating system on top of an operating system, so to speak. It's a lightweight operating system. It doesn't take up that much memory, but it does take time to load. So you won't have the same performance, you won't have the same speed as you get with a C++ program or a C program. In fact, C is going to be a lot faster than C++ because there's a lack of support for a lot of other features that you don't really need. Actually, if you take a look at this site here comparing Java with C++, which is not really part of the course, but I will assume some of you probably have a programming background in C or C++. It's probably the most common language that most, especially undergraduate students, most of them learn eventually if they're a computer science person. If you're just coming from a business background and you're just switching into computer science, software engineering, you have no background at all, Java's easier. So you've picked a good language because it's a lot easier to learn than C or C++. You don't have to know anything about C or C++. So what you're going to look at in this particular course is the Java 2 platform, and you have to install it. It's not, you'll probably have the JVM on your system. If you've ever loaded an applet from a website, if you've ever seen the little Java icon show up on the lower right-hand corner of your screen, it's hard to find a Windows computer that doesn't have the JVM on it because a lot of internet applications use it. You have to actually install something else. You need the JDK as well. You can install it on Windows, the Mac, follow the online instructions. That's the best way of getting it installed. And these online instructions are what I've been talking about in terms of those tutorials. And what I'm going to do now is kind of give you a rundown of how it works. And we're not going to really talk about or focus on the source code, but I want to basically run through. You downloaded it, you installed it. This is the interface that you're going to get. This is what you're going to work with. Run through what I call the Hello World, the first program. Kind of get you up to speed on what we're talking about, put everything into reference, and then I'll show you on a Windows partition what it looks like. This is why I say this lecture is really boring for people who already have a background in this, but it's kind of interesting for those who don't, because it's like brand new to them. So getting started, number one. As I mentioned before, all Java programs are written in a text file. And note number one to write down, cause of all of the errors that happen for Hello World, first brand new people that try to run and compile, is they name the file wrong. The name of the file, and this is something that's consistent among everything, is the same as the class that's defined in the file. So if you're going to write a program called, in this example I see it says Hello World app, you can call it anything you want. There's no naming problem at all. You can't start the name out with a number or a special character. It has to start out with a character, regular old standard character. It is the convention, although not the rule, but the convention to use a capital letter as the start. If you name the file, if you name the class Hello World app.java, and hopefully you can see what I'm pointing to with my mouse here, the file has to be named Hello World app.java with a capital H. If it's a small h, it's going to give you a compilation problem. And the other part that is required is you have to put a .java extension on the end of it. And it has to be written in a text format, in a text file. Believe it or not, I have had students try to use Microsoft Word. Microsoft Word is not a text editor. it will give you a problem because there's other formatting stuff that gets put in there. So Notepad or Eclipse, and I'll show you Eclipse later on, will work. In fact, I'll just show you the text, the old-fashioned way of doing everything with text to begin with. So you open a text editor, you define a class, you call it helloworld.app, you save it as a text file, and then I'll show you the compilation. Java is case sensitive, and don't worry about the code here when we get to the Windows. Give me a few minutes, I'll talk about the code in a lot more detail in a few minutes. But to compile it, we run a command called javac space the name of the file, for which we put the extension on the end. And it generates another file. What we have in red up here to show you is the text file of the source code that gets generated into a .class file. The number one next question, after they figured out they can't use Microsoft Word, the next question is, well, how do you run it? It's not an exe file. Everyone's familiar with Windows, exe files, .com files, .bat files, executable files. This is not an executable file, believe it or not. It is a .class file, which is an object code file that gets executed in the JVM environment. And the only way to do that is to actually type in the word Java space and the name of the file. If it's not a file that has anything in it that runs, nothing happens. It just sits there, and it comes back to a prompt. If you put something in there, then something happens. And I'll show you about how to use multiple files. If javac is not recognized as an internal external command and you get that error message, it means you didn't install Java correctly. It means either you don't have it installed, the JDK portion, or you have it installed but you haven't set your path, you haven't set your environment variables yet. If you go through the tutorials that I have on that website, it's going to show you everything you need to do to download, install, and to configure Java. And it's best to kind of go through that. It would take me too much time to go through it. But you have to set the path environment variable to get the javac command and the Java command to actually work. Now to run the program, instead of typing in javac, and I'll run through this as well. I'll just run through this in a few minutes to show you how to do it. You type in Java space the name of the file. And note that the command Java, not javac, is referred to run it. The interesting thing is you don't put the .class file. You don't put the hello, which is kind of inconsistent. If you type in javac to compile, you actually have to include the .java, the extension. If you just type in Java, you just put in the name of the file. You don't have to say .class, which is weird, in my opinion. If you get an exception, then you need to set the environment variable for the class path. Because here's how it works. So if you guys hopefully are familiar with DOS, Windows, DOS. So we don't remember the path in the old days because we can put files everywhere we want in the directory structure. We can call them from anywhere if we put it in the environment and it's in our path. We have this thing called a class path. It's a little different. The video will show you how to set that as well. That actually sets the .class path. So the JVM knows where to go out to look for all of the supporting files that it needs in order to run the program that you're running. Because it's an operating system inside of an operating system again. So it has the class path is going to tell it where to find everything in terms of the class files, which is why they call it a class path. So, and then, let's take a look at the language. For a few minutes. Actually, you know what? Before we do that, let me show you what I'm talking about, and then I'll come back and look at the language. I have a Windows partition, as I mentioned, on here. Oops, this was supposed to switch to it. Here we go. Oh, that's why I fell asleep. So. All right, I have taken the liberty to kind of create my own Hello World program to start out with, and I have a way of making this bigger. Let's see. There we go. Super size, so you can see it. The local disk, maybe I made it too big. I don't know. Let's take a look here. I got hello world.java. It's a text file. This is what we're basically showing you on the slide. Oops, let me make it a little smaller. It's a little too big. There we go. All right, so here, make it this way. So the name of the file for you brand new Java people, it's hello-world.java. If I change the class in here, then I would actually have to change the name of the file because it's gonna give me an error message unless it matches exactly. And this is actually not a bad time to kind of talk about what it is we're creating. Each of these files contains one or more classes. If you put more than one class in a text file, it will create more than one .class file. That's another thing that a lot of new students kind of look at that and go, how come I got 5 different files that come out of this? What it really wants to do is create .class files for you. And you have to define them, hopefully, within separate files. But you can do it all in one if you wanted to. It saves you time a little bit, but in the future, it's not a good idea for inheritance and stuff like that, and I'll talk about that later on. So let's take a look at this. And if you're familiar with functions from a C or C++ perspective, you already know what this kind of looks like, except for, in fact, it actually kind of follows the same format. You have a data type and you have a name. The data type here is class, because we're creating a class. We have an opening and we have a closing bracket in here. That's going to be our opening and closing. That's going to enclose everything that's part of Hello World as our class. And inside of this, we also have another set of opening and closing brackets for what is referred to as a method. So that this actually looks like an old C++ function, actually. Methods are nothing more than a function, believe it or not. Inside the class, if we left this out, the thing would actually compile just fine, but it was not going to do anything. So in order to do something, we have to actually have a main, and this kind of goes back to C or C++. We have kind of a main starting point in our Hello World program, which is actually kind of called the driver. I call it the driver program. It has a couple different other words to it. Some people call it main. Some people call it the main program or something. It's nothing more than a function. It's a method inside of the class. What this is going to do is this is our first kind of exposure. We can't say like printf like in the old days because that was a function that we ran, printf. Instead now we have to use like objects. So when we say system.out.println, we're creating and we're running an instance of a system object that gives us system IO, input, output. And we're running a method out because we want to put output. And we're running the print line method from out that says print and then put a line return on the end. There's also a print. You can leave out the ln. There's different variations of it. And this is when I say the DDL and, oops, I erased it. The DDL and DDL text is going to give you every one of those options. It's going to give you a lot more detail about how to actually print something to the screen. But what we're printing is Hello World. And this is my comment down here. It looks like C++ actually. In fact, you'll also notice we have a semicolon at the end of each line, you know, just like C or C++. We don't have a semicolon at the end of the class definition though, which is, it's not like a structure. It's not like sometimes in C or C++ you actually have to put a semicolon at the end of the, no, you don't have to worry about that actually. You do actually have to put a blank line at the end, otherwise you'll get an error message, believe it or not. So if I save this text file and I go and I run those commands that we just looked at a few minutes ago, I changed the directory, let's say to the, I changed it to the main directory, which is I think where I have all this stuff located. Yep, there's Hello World. You see I have a Hello World right here. When I compile it, I get Hello World class. I'm going to delete the class right now. There we go. So I have the .java file. I've had some students try to rename that to .class. That doesn't work. You actually have to compile it. The syntax for compiling, oops, there we go. If I have to type in Java C space and the name of the file, if I make a typo, if I say lowercase HELLO world.java, it's going to come back and give me an error message. It's going to say file not found. That's what I mean by case sensitivity. It's actually very case sensitive. So if I go back and I change that H and I give it a capital H, then it's going to find it, which means you can actually create this really bad practice. You can actually create a lowercase and an uppercase. In fact, this is the other thing what happens is when students start creating these files using Notepad, is that they'll save it as, and then it'll be a lowercase or it'll be an uppercase. And the case is going to cause you problems. And you can actually have two hello worlds, one with a lower and one with an upper, and have two different files, which is not what I would call good programming practice. So now if I press return on this, it is going to come back with an error message because I misspelled something. You're right, I have a W in there. There we go. Hello world. Let's just try it again. If it comes back with nothing, that means it's good. I know, it's like there's no user, there's nothing, there's no satisfaction at all. All right, so if I type in Java space hello world, it runs it. And what does my program do? Oops, my program did nothing more than print out to the world using system out print line hello world. If this is giving you major complications, get the Deedle and Deedle text and maybe have signed up for the wrong course is one thing. This should be extremely easy. This is just a review for people who have not actually looked at this in years or are brand new but have a little openness who can kind of quickly learn stuff, and this is good. I can't actually go any slower than this. I can try, but I can't actually. This is not good. All right, let's bump it up a little bit here and say, well, we like to use something called Eclipse, maybe, as an example. So this is all fine and dandy, this whole Notepad thing, but there's another program that I prefer, and the program is called Eclipse. If you download it, actually, here, let me close it so you can kind of see what I'm looking at. I've got it installed. You get like a purple little icon that shows up on the bottom. If you go through the video, it'll show you. But let me just show you how easy it is actually to use Eclipse. Maybe I should have just left it up. Who knows? But it's starting to load. In fact, it looks like it kind of hung, but it doesn't. There's a little green bar that shows up on the bottom eventually. There's another program I like. It's actually called JGrasp. That one's not bad either. All of these IDs are free. What this is going to do is it's going to color code the text for me. So it's also going to give me some fancy options. If you take, last term actually I taught the Android application development course. We used Eclipse as the IDE because you can load in the libraries for Android. And you just select Android as the project type. So Eclipse is actually kind of good for that. So if you get familiar with it as an IDE or as a tool, it reminds me actually of the old Visual Studio before the .NET. Like version 6 or 5 or 6, which was kind of easy. I'm going to say here project new, file. Oops. What I'm doing up here is I'm going file new, and it's built for Java. So if I just say Java project as an example, it's going to build a Java project for me. Give it a project name. I'm going to call it hello as an example. And say finish. You can fill in the other package information. We haven't really talked about packages or anything. I'm going to get to that as well today. But now up here I have some other examples up here. I'm going to leave them alone. This is how easy it is to actually use Eclipse. What I have up here is a hello pet project in my project explorer. In my source, I've got nothing actually. I don't have anything. But what I can do now is I can say file import as an example, and let's go take that file I just looked at and that hello world one. I can go and select file system. I actually have a video on how to do this as well if this is too fast for you. So this is one of the other video topics that I have out there. Oops, I want to go computer and C drive. Oops. And here's that hello world I looked at. Hello world. So I've taken this file. Let's say I downloaded it from the internet or something. You know, maybe I found a source code example on bhacker.com, so I want to run it, I want to put it into an Eclipse project. Basically, that's what I've just done a second ago. And it's putting it into a default package. That's the other unique thing that we have with Java, is we have this package concept. So it's different than the project concept. The project concept is very similar, like the Visual Studio concept of a project, just putting a bunch of files together. It's really nothing. You don't need a project to actually create multiple files, and we'll see that after lunch when we look at inheritance. Because we can actually have multiple files that all work together, they have nothing that's really tying them together in terms of an IDE or something. But what's good about Eclipse is here, if I double click on here, I've got, let me close these other files actually. I've got my Hello World file. This is the same file that I showed you in the Microsoft Notepad. But it's now it's all color, you know, so I got colors on it now. So I got the keywords in color. I got the green text, that's a comment in here. And I don't know, a lot of people find this a little bit easier, a little user-friendly. You know, if you hover your mouse over, it'll say stuff, you know, error messages and stuff like that. Or it'll tell you, it'll give you some recommendations, and you can select from a couple of options, and actually it'll automatically try and fix your program for you. If you click on it from here, and this is the other part that is really nice, is you don't have to remember any more commands anymore. So you can actually, you know, right-click on Hello and say build, or actually, let's just do it this way. Project. Wait a minute. Hold on. Run as Java application. What I'm doing, instead of clicking on the project, I click on this .helloworld.java file, and if you go run as Java application, it's going to have to compile it first, which it just did a second ago. Oops, and then the output is running a little slow. Shows up at the bottom here, so you don't have to actually have to exit to DOS at all. The interface will allow you to compile it, run it, test it, do everything you need to right here from a point and click, kind of an icon thing. There's a tutorial that I have on using Eclipse as well on the YouTube channel that will give you a lot more detail. That's just kind of a brief introduction to what it looks like in terms of the interface. So, okay, back to the lecture part of it here. So, we made it this far, and this is kind of, again, going to be boring stuff for people that know programming already. But what we're looking at is language concepts, basic concepts you want to be familiar with, and this is basically all you need, essentially. As long as you know about data types and data, how to use a variable in a program, it's the same, because what we're going to do is going to take the variable concept, turn them into data members or fields, which is going to be information that we're going to be storing about each one of our objects. And then we're going to create methods, which are functions. So if you're brand new to programming, what you want to look up essentially to get you started is the use of variables, which is going to be chapter 1 of that deal text. And the method concept, or how to create a function, is what you're going to need. And that's all the programming skill you actually need to work with objects, with classes. So in terms of a data type, just to familiarize with it, in Java we have 8 primitive types. If you remember a couple of them, you probably have enough to be armed and dangerous. You're going to want to know, well, string is not going to be a primitive, it's going to be a class type. But primitive types are Boolean, true or false, bytes, shorts, longs, floats, doubles, characters. Most people are going to be using characters and doubles or floats as a basis. And a float and a double is basically decimal precision. So instead of an integer, which is like a 1, you know, with a double or a float, you get 1.5, 1.5555. And depending upon how much precision you want, your float's going to give you a wider range than a double. So that's what your choices are. In terms of class types, string is actually going to be the one you're going to use probably most often in order to hold a string variable or string type. Integer, arrays, frames, objects. As we go through the course, I'm actually going to expose you to using object types and calling objects within objects as variables. That's going to be your big difference with Java versus something else you may have already experienced with. And array types as a concept. If you're brand new to programming, you want to look up arrays, because arrays are used a lot with objects, because you can create many different objects and hold them all into an array of objects. So the variables themselves work, and here's some examples on the bottom if you're brand new. The data type space the identifier or the name of the variable with a semicolon at the end. We have a thing called initialization and declaration. To declare a variable is to say like integer x. That would be a way of declaring a variable called x of type integer. To initialize it would be to say x is equal to 5. You can do them on separate lines, you can do them together. This is identical to C and C++, actually, and also BASIC, believe it or not. It works the same way. Boolean b is equal to true, frame window, win is equal to new frame. This is the new part. I'm going to go over this in a lot more detail, actually, creating new objects. In C or C++, we have new and delete. In fact, you use the same syntax to create an instance of an object in C or C++ using new. The only thing different with Java is we don't have delete, because we don't have dynamic memory. When you use new in C++, you're creating a piece of dynamic memory that can only be removed by delete. In Java, you just say new all the time, no delete, because that's what the garbage collection I've been talking about takes care of. It goes in and automatically deletes stuff that you've used new with, that you've created, that you're not using anymore. So it's one of the advantages you have. In terms of flow control, another thing you're going to want to look up as a brand new programmer is going to be the if, the if-else, if, the switches, the do-while, the breaks, the continues. Same as C++, actually, same. And here's some supplemental reading. These links actually work. Which is why I don't actually have a textbook for this course. There's a ton of information online. This is lecture 1 that can be downloaded from bhacker.com. You can go in and click on those links. Those are not bad, actually. The tutorial on the bottom, if you can't figure out the video tutorial, it's not a bad reference to kind of get a basic understanding of how to install. So, kind of went through that on the fast side. However, there's more. It's kind of a overview of a lot of different features, most of which we'll find in time to be relevant in terms of basic understanding. Let's see. I want to go back here. Let me just minimize this. We're going to go a little bit longer, then we're going to break for lunch. Probably another half an hour at the most. And then we'll break for lunch. Does that sound good? Rather than taking a break and then coming back. Okay, that, believe it or not, was a quick overview of Java as a programming language. Now what I want to do is talk about object orientation in terms of the object. And I'll start in and then I'll continue this after our lunch break. So a lot of you have some procedural programming experience, and so this kind of puts kind of the two functions, the two procedural versus object orientation into perspective. And in terms of what we're looking at, is we have this unit, and the unit is either going to be a function, or it's going to be an object, or it's going to be a procedure or module. There's a lot of different names for it, and the unit is essentially the programming functionality. In object orientation, everything is the class. We can't do anything but create classes. And inside of the class is when we have our functionality. And so, versus, and if you look at the bottom of the screen, you kind of see them side by side. In the procedural program, we started with line number 1. We went to line number 2. The old days when you learned BASIC, we actually had line numbers. And then they took away the line numbers. And I said, well, look, take away the go-tos. Let's just have functions. That's when we started going. From here, the function allowed us to repeat a bunch of code. So rather than figuring out, year-to-date sales over and over and over again in our code, we created a function. We called the function, allowed us to run it, write the function once, call it many times, and then we It kind of messed up our flow control though, which kind of messed up our line numbers, which is why the line numbers went away. Because now we can go from here, we can go jump to this function, jump back to the main program, jump to another function, jump back, which kind of gave us procedures, procedure by procedure. Object orientation doesn't work that way at all. Instead, we create a bunch of classes. We create instances of the classes, and we run the methods on the classes. And the methods allow us to get set information and give essentially the classes object life and gives us objects that interact. And it kind of mimics the, well, they say it mimics the real world. I don't know. It kind of mimics a fake kind of world of objects talking to each other, which doesn't run from the top of the code to the bottom of the code. In fact, there's no sequence to anything anymore because objects have life. In fact, objects can contain, they're objects themselves. They contain, sub-objects inside of them that call them. So the kind of line-by-line old thinking kind of has gone away, and we don't have this whole procedure or this functionality, or this kind of concept going on anymore either. Instead, we have the kind of the employee object that talks to the staff object that talks to the boss object. And I'm going to use an employee example after our lunch break to kind of see how the objects work together, and I'll show you how that actually works. So the concept of the class and the object, this is why I keep talking about classes. Those are the objects. So the class refers to the blueprint, defines variables and methods that the object supports. And so the object is an instance of a class. So we have one class that we define. We put it in our source code. That's what we're writing. And these classes all go in their separate files, as you've seen so far. And then we have what's called a driver program, or a main, which is a class in itself that is the program. And the program goes out, or inside of the program itself, we make instances of all the classes. So it's like we have this piece. We're not actually calling the classes like functions. Instead, what we call is we make instances. We instantiate lives. When we make an instance, what is it? It brings it to life. Kind of. So you have kind of think about virtual reality here, in a kind of a weird way, in order to understand what's going on. But the object is the instance. Each object has its own existence. As an example, you guys are all instances of student objects. So each one of you has a different name, different student ID, different information that's being held. Each one of you actually has different behaviors associated with you. Some of you take this class, some of you take another class, some of you have different characteristics, but you all have the same makeup. If we put you up against a line, you'd all be instances of student objects. That's one of the biggest problems, believe it or not, in object orientation, is having objects of the right type, identifying the right type of the object, and actually using you correctly. So you're all students, so if I take one of you and say, you're now a teacher object, you're not going to know what to do. Well, you might. Some of you might have teaching experience. You might know how to play both roles. But you're probably really better at the student role. So when you start defining your objects, the biggest problem is what's the student, what's the teacher, what's the desk, what's the chair, and making sure that you keep the concept and in the abstraction of the concept, making it logical, making it so students only act like students. Chairs only act like chairs. So inside of the chair, the student, the teacher, all of these objects that you're creating, you only really have two components, which is not bad if you break down the abstraction. You're not writing code like a function. Instead, you're defining characteristics. So we have two components of this object. We have properties that describe the object, and we have methods or functionality that the object can do. So as a student, you have first name, last name, address, I don't know, you have student ID. Those are actually called fields. I like to, and that's the top item here. And well, there's three kinds of members. Well, basically two in a nutshell. There's a third component. I'll talk about it in a second. I actually like to call these data members, and then I refer to the methods as member functions, because I'm a C++ programmer. That's where I learned everything from, and we called them data members, or data, and properties. Behaviors. So data is the field. Java people call them fields. They're data variables. Like in the old days, when you wrote Hello World or you wrote a program, you had all your data that you initialized up front. You said integer salary, or probably double salary, you know, string name, string address, all the information that you want to keep about the particular object. You don't actually have to put them up front anymore, but you do have two separate sections. So you divide out the functionality, and I'll show you that in a few minutes as well, probably not till after lunch. And I actually like to put the data up first. Java people like to do it the second. They like to put the member functions and then the data at the end. I'm not quite sure why, but I actually kind of like to see the data up front still. And underneath the data, then I put my member functions. And my member functions are the methods. Some people actually call them messages as well, because this is how the objects communicate with each other. So the object identity holds the field information, your name, your address, your student ID. The method says drop a class, add a class, attend a class, all of the behaviors that your object is going to do as a student, eat, I don't know, drive, fly, do whatever the object does. That is enclosed in the methods. And the methods are the executable code that built from statements. That's the programming part, if you think about it. That's when you're writing the logic. And then we have nested classes and nested interfaces. I'll talk about that a little bit later. So what we can do with this is we have what's called accessor and modifier methods. And they actually work directly with the fields or with the data. So as an example, as a student object, you probably have a name, hopefully, and that's going to be a field or data member. And you can use a method to say get name, tell me your name, and the student object would say Barbara, or would say basically output their name, or set the name. Sorry, we're going to change your name. Okay, Mary, whatever my new name is, gets changed through the methods. And when we build the class structure, this goes back again from C++. It's the same concept, actually, if you're familiar with it. All of the data members are normally private, which means inside of the class, no one can change your name outside of your class. But the inside of the class, if you decide you want to change your name, you can. So we have information that's protected inside of our object. Our name, our social security number, my address. I'm not going to give you my social security number. I'm going to keep it protected. It's private. So it's called an accessor method, which is our ability to access the method. It's private, which means inside of my class, I'm the only one that can access that. Or we can optionally make it public, which means anyone who wants to can change my social security number, can change my name. But you can obviously see there might be an issue with that. So we have, and I'll talk about this later on when we start creating classes, we have ways of building the classes so that the integrity is maintained, so nobody goes around and changes my social security. If I want to change it, I can. I have a method or a message that I can run that will change my name, change my social security number, and then classes who use me. And as an example, you're all students, objects, and you're sitting in a classroom. So you're actually part of another object. You're taking a class. So the class isn't going to be able to change your social security number. They shouldn't. But you can change your social security number. So we build a protective mechanism so we can have a class. Let's say you're a student and you want to run for student government. You want to be the class president. Well, then you're a class president, but you're also a student. And then you're also a human or person, hopefully. And you're also a mammal or whatever. So you can hold the whole line of inheritance that happens through you as an object. And that's the concepts that we'll be talking about in terms of the hierarchy of classes. As an example, we can build a person. And that person can be an employee. The person can be a student. The person can be a teacher. And then that student can be a student of computer science, of engineering management, whatever. So if we build a hierarchy, we reuse the components. So every time we want to create a new student, we don't have to redefine a person or a human. in order to have that enclosed in our understanding of these objects. So we built a hierarchy that gives us a lot more functionality, and we take everything we used to have. If we were to build a student, we'd probably build it from a human or a person. Take all that stuff. Don't have to reinvent the wheels. Don't have to define how many arms and legs we have and stuff like that. We already know all that stuff. Just turn you into a student. And it gives us the ability to kind of extend the concept and, not reinvent the wheel every time we want to invent something new. So here's an example class. We looked at Hello World. It was kind of simple. This is one with a lot more components in it. And this one here has got, it's a pencil. So we're defining what we're calling a pencil. And we see we have the word public string color equals red. And we have public integer length, public float diameter. So these are all data pieces about the particular class pencil. And it's a color, a length of the pencil, diameter, how thick the pencil is. And we're using public for everything. And because we're not going to do anything with this. It's just an example. You can actually leave out the word public. If it's going to be public, if you leave it out, it's public. It's only a matter if you want to make it protected or private. And I'll talk about protected, and if you haven't talked about that yet. But these would be called our data members or our fields. And then here's another one. We have public static long, which is going to be a next ID. It's going to be an ID. So we're going to put ID numbers on our pencils. And here's a method example, and it's going to be a public void set color. And our method looks like an old function in the old days. It takes on a parameter. The parameter is going to be new color. And the color is going to be equal to new color. And this color here is this color up here. So when we make a new instance of this particular class pencil, we call it pencil number 1, it's automatically set to red. And then we can run pencil1 dot set color and then pass it information called blue, and we'll see this work in a real example. We can change the color, make it equal to blue. So each instance of pencil that gets created, so if I say, pencil 1 is equal to new pencil, pencil 2 is equal to new pencil, pencil 3 is equal to new pencil, and change the color, they all have their own separate value for each one of the colors. And that would be considered an instance variable. Same thing with C++. We also have this thing called a class variable. Class variable keeps track of all of the instances. And it's a variable that's shared by all of the instances that are associated with a particular class type. That's what this is down here. And we'll see that working after the break. Where we have public static. Static creates a class level instead of an instance level. Which means every one of our new pencils, if we increment the ID, we change the ID, then it's going to know which the next value is. The next ID is shared by everybody. So every instance of that particular class that we create doesn't have their own value. It's sharing something that's owned by all instances that are created of the same class. So what we do is we create instance variables and class variables. We create methods, which are these down here. And we set the variables using the methods. And we provide methods to perform behavior that we want. And then we just create these instances and we run them. And then we can, as an example, run a check registry where we can keep track of the next check number. And then every time we create a new check, it gets a new number that's incremented from the old series that was running. So, which is what this particular next ID would actually work as. If we were creating pencil number 1, pencil number 2, we can keep track of the pencils by giving it a next ID, which is going to be a running total of all pencils that we've created in that particular example. So, in terms of the field declarations, we can actually, just as a side note, because this is all public, if we created pencil 1, which was using new pencil, and I'll show you the syntax for that in a few minutes, we could say pencil1.color is equal to red, or pencil1 dot color is equal to blue or whatever. Because it's public, we can get at the particular data members from what I'm calling the driver program from main. If we were to say private here, we would get an error message that wouldn't allow us to do that. Public is basically allowing us to break the rules, essentially, and run anything we wanted to from this particular class. So the field declarations. So as we've seen here, we have the fields are color, length, and diameter. We're typing and creating the type name followed by the field name, and then optionally we're initializing it. So this is, this is the initialization clause. This is the declaration. So it's basic C++ Java programming. And we have the private data versus the object type, primitive data, excuse me, versus the object type. This is actually, string is an object. And you might actually notice, you can tell the difference real easily. Remember when I said hello world, I said capitalize it. All classes need to be capitalized. One trick you can actually use is if you want to know whether it's an object type or whether it's a built-in primitive, built-in primitives don't start out with capital letters. So most people, when they first start learning in any language in general, they start messing around with integers at int, capital int, or they always lowercase. But you can tell string is an object because it's an uppercase. It's actually string.java. So turned into string.class. When you make new string, you can actually use it. You can say, in fact, this is proper syntax for creating a new string object called color. What this means is you can run methods on string. So string, let's say color.getLength, color.set, trim this, compare this. So the integers themselves, you can typecast, but you can't really do very much with the integers or the floats or the built-in primitives because they're just regular, traditional data types that you'd normally see. So field declarations can be preceded by different modifiers, and this is the modifiers I'm talking about here. And the modifier here we see is static. And the static is essentially one of the access controls. So we have final, I'll talk about static, I'll talk about a little bit more, and then the public, private, and the protected, which is the modifiers themselves. And in terms of the field modifiers, private members are accessible only inside of the class itself. Public's, on the exact opposite, maybe I should have switched the order here, is available to anybody. So it's the exact opposite of private. And then protected, classes that are inherited from our class. I'll talk about inheritance after the break. They're public, but everybody else are private. So protected says, well, we're going to protect you from the public. So we're private to everybody else, except for if we've allowed you to inherit from us. Then we're okay. We're public. You can go ahead and change us because we're giving you protection. We're protected. It's not the public. It's this inherited class that we're dealing with. And then we have this package concept. Packages are kind of interesting in Java. So you remember going back to Hello World with a notepad. We didn't have a project. We didn't have there's no structure to this. Packages is the structure. And packages is kind of like a directory structure, if you think about it. In the old days, it used to be URLs. It used to be such dot such and such, and you resolved, and the dots were directory levels, kind of like the same way as a URL works in terms of the location in the subsystem. Same concept, actually. We include things in packages. We do that because now we can have multiple classes with the same name in different packages with different functionality. So we can swap out packages, include things in different packages, and we've basically changed our environment scope, essentially. So packages is kind of like the scope of the program. We always put a package at the top to say where does this class belong, and I'll show you an example of how to do this as well. And then we can keep things organized. It's kind of like a directory structure in a lot of ways. In fact, you can store it, and you should be storing it in the package location on the disk. And I'll show you an example of that as well. But the package is it's accessible within classes of the same package of the same class itself in terms of package concept. And here's an example of what I was talking about before in terms of the public, the private, and the protected. And I think I'm going to What time is it? I think I'll actually end after this. End for lunch after this example. We'll come back. This is a good stopping point because it kind of focuses on a point I've made already. We have a little X here. We said P1. So we've created a pencil. P1 is equal to new pencil. That's how we created our instance. These are two separate files. We have pencil.java and we have create pencil. This is what I'm calling the driver. This is what I'm calling the class. So we have many of these. We only have one of these. This is our program. We want to put this in two separate files because we can have pens, pencils, markers. We can have different types of classes. And we can use them all in this driver program. And they're all kept separately. So we can create pencils, we can create different types of pencils from pencil as a base class and extend the functionality. We don't have to worry about this stuff. This stuff is just there because we want to run it. So we usually have our driver programs or our programs separate, and then we have our class files that are separate. And so if we keep them separate, then we can kind of figure out, we can put them all in the same package. But then we can kind of better organize everything for reuse in the future. Because why do you want to reuse your driver program when you're writing a different program? So it's kind of a waste and it kind of gets in the way. So this is the same code we looked at already. This is that pencil code. And out here in the driver program, this is create pencil. We have our static void main. We don't actually have a void main up here, which is kind of the hard thing for C++ people to kind of build out of. Every file doesn't have to have a main. In C, they always taught you, oh, main, you have to have a main. No, you don't need a main anymore. That's just for the driver program. If it doesn't have a main, it's ignored. It doesn't run. So the only thing that does run is the main, actually. So that concept kind of still is there. If we did pencil P1, pencil space P1, creating an instance of pencil, it's just like the same way we were creating variables, declaring variables in the same kind of format. The name of it is P1. If we say P1.price is equal to 0.5 or 0.5f, we're actually saying this is a float value explicitly. We don't even have to do that. We're going to get an error message because up here we have the price is private. So this is going to come back with an error message essentially. It says no, P1.price, that's it's not access. The price has private access in pencil, which is basically what's going to come back and say. So, this is a good stopping point actually, because when I start talking about static, I have to talk a little bit more about classes and instances. So, let's take a lunch break for an hour. Is that enough time for you guys? I know it's freezing in this room. It would be nice to get out of the room. Okay, so we'll break for an hour, and then we'll come back and I'll finish this lecture and we'll go a little bit more. We're going to actually get through inheritance this weekend. So we're starting out kind of at the beginning, but then we're going to jump. So we're going to jump significantly after this break. So.